lower cutoff frequency determined by the stage that having the highest lower cutoff frequency. Hence, because see, one amplifier, all the amplifiers are contained in cascade, right? Even one amplifier, if it is not working good, or even if one amplifier is very poorly designed, that is going to be a drawback for your system. It will ensure one poorly designed amplifier can spoil the complete circuit. Okay, it is going to spoil the complete circuit. So care should be properly given to each and every stage of amplifiers for designing them. Okay, so the effect of increasing the number of stages, how many stages you can have, what is the upper cutoff frequency and lower cutoff frequency are shown in figure 11.43. You can see this is one single amplifier. You can see how how broad is the gain, and this is for second stage. You see the bandwidth is getting reduced, the curve is becoming narrow and narrow. This is for a third stage. You can see how it is becoming narrow. For fourth stage it will come like this. This is for a fourth stage. Fifth stage, very narrow. Sixth stage, very sharp. So you can see as you increase the number of stages, the bandwidth becomes narrow and narrow. Bandwidth is f2 minus f1, right? The bandwidth becomes narrow and narrow. So you can see for one stage it is very big. For two stage, it is getting compressed and compressed. One point you will get a very sharp response and the bandwidth will become a single frequency. So instead of having a flat constant frequency, at only one frequency you will have a peak. So there is no F1 and F2, you called it as F0, resonant frequency. So that condition might come if you increase the more number of stages. So you can see at F1 and F2, for the first case, it is minus 3 dB. Then it has come to minus 6 dB, minus 3 dB. Now it is getting closer and closer and resulting in the drop in bandwidth. For single stage, you can see it is, they have calculated to be minus 40 dB is the slope. Then it is slowly coming down. You can see the slope is becoming very steep and the curves are becoming very close. So at one point you will find that instead of having F2 minus F1, you will have a single frequency where the gain is going to be peak. So in that case, the bandwidth is going to be just equal to F0. Okay, so that is also possible. Okay, so the flatness of the gain characteristic will slowly become short and short, and that one, the instead of becoming a constant value for a band of frequency, the gain will become fixed for a particular frequency. If not, that is also possible in multi-stage amplifiers. So you should not think when you have more number of amplifiers, the behavior is going to be same. No, the behavior of each amplifier is going to decide the overall behavior of your multi-stage amplifiers. So that is what is given. So for a three-stage system, what is the bandwidth? For a two-stage system, what is the bandwidth? So they have given how the variation in slope. The slope will be slowly increasing. For one stage, it is minus for two stages, it is minus 12 dB per octave or minus 40 dB per decade. That is how the variation is. For a three stage, you see it is minus 60 dB. So you can see the slope is becoming steeper and steeper, which will result in reduced bandwidth. Assuming all the stages are identical, you can find what is the bandwidth of the overall circuit containing n number of amplifiers. N is going to be the number of amplifiers that are going to be cascaded. So n is equal to 1 corresponds to a single amplifier. And for multi-stage amplifiers, we will always start from n is equal to 2. The minimum stages considered are